Hi everyone, welcome. I assume you're watching this because you want to know what statistics is all about. If you are taking a class in statistics, this introductory tutorial will familiarize you with the basic concepts and terminology that is used throughout your course. Please write down the terms and definitions as they appear on the screen. So let's first begin with a definition. What is statistics? In a general sense, the term statistics refers to the information we get from data. Numbers and data are all around us, and if we make the data mean something, it becomes more useful to us. When baseball fans discuss a ball player's statistics, they are using the word statistics to refer to the numbers on the back of a ball card. These numbers may describe the player's runs, errors, hits, and so on. On the other hand, when business people refer to statistics, they are usually discussing sales charts or business expenses. These statistics can be in the form of numbers or shown graphically using some sort of a chart or a diagram like the one shown here. When people are referring to statistics as a field of study, they are talking about a branch of mathematics that looks at ways to collect, analyze, interpret, and present data in a meaningful way. Without the tools to do this, the numbers would just be numbers. The field of statistics helps us to make sense out of otherwise meaningless numbers. To understand some of the basic concepts of statistics, we need to discuss the terminology that is used. Let's start with two related terms, population and sample. The term population refers to the set of all elements under study. The term sample refers to a subset of the population under study. Suppose we are interested in determining something about the population of students at our local university. Let's say we are interested in the typical color car that is preferred by these students. Or maybe we want to determine the average number of credits our students take per semester, or the average monthly rent they pay. If we are interested in all the students at the university, we could define our population as all students attending Alpha University during the spring semester. This is our population. We decide how we define our population. We could decide to define it more narrowly and say our population is all marketing majors taking 12 or more credits during the spring semester. So now, instead of the population being defined as the entire university, it is just focused on marketing majors. For now, let's stay with all students attending Alpha University. And there are all of our students. Once we have defined our population, we could take a few of these students, or a subset, and ask them the questions we're interested in. This subset would be our sample. This is a very simple concept of taking a sample from a population, yet it is the underlying force of almost everything we do in statistics. Let's imagine that this large circle represents the entire student population at Alpha University. Each of the red dots represents an individual student. One way to gather information or conduct a survey would be to ask each and every student, whatever question we are interested in answering. This could take a long time depending on how many students there are. We could also take a simpler approach and ask just a few of the students these very same questions instead of asking all of the students. This smaller circle would represent the subset of students that we would survey from the population. This would be our sample. What is extremely important in taking a sample is that the sample of students we question are representative of the population. If the sample gives us a good picture of what the population looks like, then we have selected a representative sample. And if the sample is representative of the population, then we can infer certain things about the population from the sample. We will talk more about this concept a little later, but for now, it is important to understand that samples are taken to save the time, money, and effort of examining an entire population, especially if the population is very large. It is important to understand some of the notation that is used in statistics. Big N is used to denote the size of a population, and little n to represent the sample size. So for example, let's say our university has 17,000 full-time students registered in the spring semester. Then big N would be 17,000. Let us say we're going to survey 500 of these students. then little n would equal 500. This would be our sample size. Now let's suppose that we have the time and resources to question all 17,000 students, that is the entire population. This would not be considered a sample. This would be called a census. The United States government conducts a census every 10 years to survey the entire U.S. population. It is a monumental effort, and that is why it is done only once a decade. So we can get data from the entire population, or we can get data from a sample. Obviously, data from the population would be more accurate than data obtained from a sample, since the sample doesn't include every element in the population, but only a subset. The measurement we get from a population is called a parameter. When the measurement comes from a sample, it is called a statistic. So to rephrase that, the term statistic refers to numbers that come specifically from a sample. If the numbers come from a population, they are called parameters. There are some more terms that will pop up through your study, whether it is in statistics or research methods, and you will need to familiarize yourself with them. They are data set, elements, variable, and observation. Let's go through each of these one by one. A data set refers to all the data that is collected in a particular study. So if we ask a sample of 500 students what color car each of them drives, then all of the data we collect from the survey is called a data set. An element is the entity on which the data are collected. So in this example, it would be our students. A variable is the characteristic from each element that we are studying. In this case, it would be the color car they drive. And finally, each measurement is called an observation. Let's review these terms carefully one more time. We said that a data set refers to all the data that is collected in a particular study. If we go out and collect information from 500 students, then that information that is collected is referred to as data, and all the data pertaining to that study is a data set. Remember, an element is the entity on which the data are collected. In this case, it would be the students. If we were examining light bulbs to determine how many hours they lasted before burning out, then the light bulbs would be the elements under study. A variable is the characteristic from each element that we are studying. For our student example, the variable of interest would be the color car they drive. For the light bulb study, the variable would be the number of hours the bulbs burn. Each measurement for a student or light bulb is called an observation. So if we have 500 students in our sample, and the first student we observe drives a green car, then the first observation would be green. If the second student drives a white car, then the second observation would be white, and so on. Data can be classified as either categorical or quantitative. Some people refer to quantitative data as numerical. The data that can be grouped into categories are called, yes, you guessed it, categorical data. Questions such as, "Are you a full-time student?" would yield a yes or no response. So that would be labeled categorical data, since the answers yes and no are two categories, yes and no. If we ask, "What color car do you drive?" that would also yield a categorical response, each color being a different category. These are not inherently numerical answers, they are categorical answers. Quantitative data, on the other hand, yields a numerical response. The answers come in the form of numbers. But this numerical response can either be discrete or continuous. For example, the question, "How many courses are you currently enrolled in?" would yield a numerical response. The respondent would give a numerical answer, say 1 course, or 2 courses, or 3 or 4, or so on. These responses are considered discrete variables, since they result in a counting process whereby the response is a whole number, or the next whole number, or the next whole number, but nothing in between. For example, a student can be enrolled in 1 course, or 2 courses, but they can't be enrolled in 1.6 courses. On the other hand, numerical responses that come from a measuring process give us continuous variables, since the responses can be 1 number, or the next whole number, or any number in between. So if I ask you your weight, You could give me any number or the next, or any number in between, depending on how accurate and to how many decimal points your scale can measure your weight. There is something else we need to know about collecting data. It can either be collected at one specific point in time, sort of like a snapshot, or data can be collected over several periods of time, more like a videotape. When data are collected at one point in time, this is called cross-sectional data. This is very typical in survey research, especially when business decisions need to be made quickly. Data that are collected over several time periods are called time series data. This is typical in educational research where, say, kids are enrolled in a Head Start program and they're followed for many years to see how they progress. For our own university example, we can take a snapshot of our currently enrolled students at one point. That would be used to determine how many credits they are taking on average during the spring semester. This data would be considered cross-sectional data. We get a snapshot of what our students are doing at one point in time. Or we could decide to take measurements for 8 consecutive semesters, each semester measuring the same variable, the average number of credits students are enrolled in each of those time periods. The data from these measurements would be considered time series data. The world is full of data and continuously generates data. This data exists waiting for someone to sort through and present the data in a usable fashion. Sometimes we have to go out and collect the data ourselves, and sometimes someone else has already collected the data for us. Data that already exists in some form is called secondary data. Data that we have to go out and collect ourselves is called primary data. The United States government has one of the biggest repositories of data and makes much of its data available to the public via various government websites. Let's take a look at the USA.gov website that has tons of information available for free. Okay, let's take a look at this website, and let's click on the tab Services and Information and click on Businesses and Nonprofits. Now let's scroll down. I'm looking for data and statistics. Here it is, data and statistics. Just take a look at all this data that's available. Banking data, business data, earnings data, economic data. All right, let's say we're interested in business data. Let's click on the link US Business Data. Okay, and you can see all the choices here. All right, let's click on Electronic Commerce Statistics. Let's see what's there. Okay, this link takes us to the census.gov site. Of course, you could go to www.census.gov directly, and you can see lots of statistics on e-commerce available. They're available in PDF formats or tables ready for us to use and to download. So here's tables. I click on that, and no thanks. And you can see Excel spreadsheets already filled in with data waiting for us. If I clicked on one of these and downloaded it, there would be tons of information all ready for us to use. Let's go back. And let's scroll down to a portal for statistics. Okay, here it is, statistics portals. Okay, and here you can see all of the government sites that you might want to visit. You have the Bureau of Economic Analysis, Bureau of Labor and Statistics, the Census Bureau, which is where we just were, Department of Commerce, Department of Labor, and so on. This data has already been collected and exists in some form. And because this data has already been collected and exists in some fashion, ready for us to use, it's called secondary data. All right, let's talk a little more about secondary sources of information. As we said before, a lot of data already exists in the world. Some of the data exists within your company or organization, and you have easy access to it. Other data exists in other companies or organizations, and you might have to pay for it. The data that exists within your company is called internal secondary data. Data that exists outside your company or organization is called external secondary data. The government, as I said before, is one of the biggest sources of external secondary data. There are also many other companies that are in the business of collecting and selling data. Some well-known companies that collect and sell data are Arbitron, AC Nielsen, Dun & Bradstreet, Gallup, Dow Jones, and so on. Companies collect and store data themselves. The term data warehousing refers to the process of capturing, storing, and maintaining this data. This data can be a rich source of information to decision makers, but there needs to be a way to sift through the separate out the gold. This process of sifting through the information to get useful data is called data mining. Data mining systems are set up to extract information and uncover patterns that would otherwise remain hidden. The usefulness in data mining lies in its predictive abilities. As an example, retailers such as Amazon and Barnes & Noble have been able to predict products consumers are likely to buy based on past purchase behaviors. These predictions are the result of data mining. Most of the information that is available for use through company reports and sales charts, for example, can be presented in an easy-to-read format such as a table or a chart. The data in these tables shows what the current status of events is, and it is referred to as descriptive statistics. Most of you are familiar with the back of a baseball card. You might have collected these or know someone who does. The back of the card lists the player's stats. For example, batting averages, runs batted in, height, weight of the player, and so on. This information is descriptive in nature, and it describes what is. That is what the term descriptive statistics refers to, describing what is. We can also use data from samples to help us test hypotheses about population parameters. When we are using sample data to draw inferences about a population, this is called inferential statistics. The process of using statistics to draw conclusions about population parameters is called statistical inference. Let's say we take a sample of 500 students and ask them how much they pay in rent each month. We can then use the sample statistic to draw an inference about the true population parameter, that is the true average monthly rent for all 17,000 students based on the sample data. This process is called statistical inference. Once we have collected data, we need to know the types of measurement scales and the level of measurement for the data before we can apply statistical techniques to analyze it. There are 4 levels of measurement we need to be concerned about. These are nominal, ordinal, interval, and ratio scale data. The first 2, nominal and ordinal, result from categorical data. Data that result from categories that have labels that are just descriptive are nominal scale data. For example, the color car you drive is a category of color that is just a label. A green car is not greater than a white car or a black car. The colors describe an attribute but are not ranked in any way. This type of data is considered nominal. Once the categorical data has a ranking, then we consider the data to be ordinal. For example, at a horse race, the first 3 horses come in to win, place, or show. The horse that comes in first place is called the win. Second is called place, and third is called show. These categories are labels, but they are more than nominal data since they give us information in addition to the labels. They also tell us the order in which the horses come in, first, second, and third. This type of data is called ordinal data. The second horse can come in just after the first horse, by a nose, so to speak, and the third horse may come in several seconds later. The horses are still considered to be ranked first, second, and third, even though the third was much further behind the second than the second was to the first. The difference between the horses doesn't matter. They are still first, second, and third. When the data can be measured so that the differences between the measurements is meaningful in some way, then the data is considered either interval or ratio scale data. To be considered ratio scale data, there must exist a true 0 point. If a true 0 point does not exist, but the differences between the measurements is meaningful, then the data is considered interval data. A good example of interval scale data is the temperature measured in either Fahrenheit or Celsius scale data, since the 0 value in these temperature scales is not a true value. You can't say that 20 degrees is twice as hot as 10 degrees. It doesn't mean anything since 0 is an arbitrary placeholder and not real. The Kelvin scale is used by scientists and does generate ratio scale data, since the 0 point on the Kelvin scale represents no molecular motion. When the molecules stop moving, the Kelvin reading is 0. 0 means the true absence of something. Your salary is considered ratio scale data. A salary of 0 means you made nothing, and a salary of 40,000 is twice as much as 20,000. Ratio scale data is considered the highest level of measurement and allows statisticians to perform any type of statistical analysis, including transformation and taking the log of numbers. Nominal scale data is the lowest form of measurement and allows only minimal types of statistics to be applied. Because statistics plays an important role in how we understand data, numerous ethical issues can present themselves when the data is collected, analyzed, and presented. There are many examples of unethical behavior on the part of researchers who misrepresent the data they have or use their own biases to interpret the data to best fit their agenda. As a scientist and a student of statistics, it is your duty to be fair, thoroughly objective, and neutral as you go about conducting your research. As a consumer of statistics, you should be wary of unscrupulous sources of information and unethical statistical behavior by others. Always consider the source of the information when evaluating statistics that are produced by others and made available to the public. The American Statistical Association is the nation's leading professional organization for statistics and statisticians. They have developed a report called Ethical Guidelines for Statistical Practice to help practitioners make ethical decisions. The report has 67 guidelines organized into 8 topic areas. This report is broad and includes information useful to both statisticians and users or consumers of statistical information. This concludes a rather comprehensive introduction and overview of the field of statistics. Below is a list of terms we reviewed in this tutorial. I know it's a long list, and some of these terms you might have known already. Understanding this jargon, the language used in the field of statistics, is an important first step in understanding how statistics is used and applied in our world every day.